Hello again, and welcome to another wonderful lesson with Mr. Wizzy. How about we'll call him that? That sounds pretty good. So, kick off. Find the value of x. Again, we're going to skip this over. If you want to know how to do it, again, look back at that last video. We did that in the last lesson. So I'm just going to jump right into Theorem 6.9, which is each diagonal of a rhombus bisects two angles of the rhombus. So if we have our rhombus here, as this is cutting through, it's going to bisect these two, and it's going to bisect these two, similarly going the other way. And yes, as you see here, we're going to prove this. Now, in the notes, this is a paragraph proof. So I will convert it over to a 2-column as we work through it. So number one always is the given. All right. So we have our given. From there, we're going to build two. Well, what for sure are we? Well, for one, we know that all the sides of a rhombus are going to be congruent. So that's going to be our next step, is that AB is going to be congruent to BC, which is congruent to CD, which is congruent to DA. And that's going to be by definition. So we know if it's a rhombus, we know all four sides are going to be congruent. Well, what else we know here is that this diagonal cutting through is going to be congruent to itself. So AC is congruent to AC. That's bireflexive. So if we mark that as well. So now, again, we're going to try to show that these triangles are congruent. So triangle ABC is congruent to triangle. So ABC would go DCA or CDA. And that would be by side, side, side again. So once you prove the triangle is congruent, then you can say their parts are congruent. So we're going to do this with, we want angle 3 to be congruent to angle 4. And angle 1 is going to be congruent to angle 2. And that's going to be by CPCTC. Because if they're matching up, 1 and 2 would be congruent, 3 and 4 would be congruent. Because these here, if you look at it another way, if we know these are triangles, these are actually isosceles triangles. And if the two sides are congruent, then the base angles will also be congruent that way as well. So it really wouldn't matter if we did 1 and 4 and 2 and 3, or if we do 3 and 4, 1 and 2, because they're all going to be the same. So number 6 then is our proof. AC will bisect angle BAD and angle BCD, and that'll be by definition. So, first proof done. I will let you know there's one more proof in this lesson, but it is not this next one. So, Theorem 6.10, the diagonals of a rhombus are perpendicular. So these diagonals, as they cut through, not only are they going to bisect each other because it's technically a parallelogram, but where they bisect will be a 90-degree angle, where they come together at. That's the difference with a parallelogram compared to a rhombus here. Rhombus sets it apart by saying that will also be 90 degrees. So, MNQ is a rhombus, and M, the measure of angle N, is 120. Find the measures of the numbered angles. Well, number one, yes, this is a rhombus. which for NM, this is P over here. And these are 3 and 4. So number one, with it being a parallelogram, we know opposite ones are going to be congruent. So this over here will also be 120. Well, what else do we know here? Well, we know that 1 and 3 are going to be congruent, and we know 2 and 4 are going to be congruent. Because, well, if it's a rhombus, we know all of these sides are the same, and so those have to be congruent as well. So if we look at each half here now, we know that angle 1 plus 120 and 3 being a triangle have to add up to be 180. So what's left for 1 and 3? So if we do 120 plus the measure of angle 1 plus the measure of angle 3, that has to equal 180. Now we know these two are the same, so if we subtract our 120 away, the measure of angle 1 plus the measure of angle 3 has to be 60. So if they're the same, they each have to be half. So this one will be 30 degrees. This one here will be 30 degrees. Same thing on the other side. 2 would be 30 degrees. So would 4. So each of these is 30. So knowing it's a rhombus, we know those angles are bisected. We also know that both 2 and 4, 1 and 3 are going to be congruent because it's an isosceles triangle that we're breaking this into. So each of those have to be the same, and that's how we get her out. Last one we have to prove in this lesson. So the diagonals of a rectangle are congruent. Simple enough. So if it's a rectangle, these diagonals not crossing at a 90 degree in the middle, but they're going to be the exact same as they cut through. This is a technique you can use when you're making walls or any sort of a rectangle for anything. So if you measure the diagonals of it from corner to corner, they match, you know it's all squared up. It's a little trick you can use using this theorem. So another real life application. So again, if you look in the filled out notes, this is a paragraph proof, but I will make it into a 2-column if I can. So step 1, always the given. So we know it's a rectangle. Well, knowing it's a rectangle, we also know it's a parallelogram by definition, because a rectangle is a parallelogram. We know that. So we can say that for step 2. A, B, C, D is a, I'm just going to sum it up to para. It's a parallelogram by def. Well, knowing it's a parallelogram, what does that tell us? Well, we know opposite sides of a parallelogram are going to be congruent then. So we can say AB is congruent to DC, as well as AD being congruent to BC. And that'll be by definition again. So something else we can say is we're actually going to look at this. We need to tie it in to these diagonals. So what else we need to say is that BC and BC are going to be congruent. And I'll show you why here momentarily. Which is by reflexive. So what we're going to end up doing is we're going to try to make this triangle. So if I highlight it here, that triangle be congruent to this other triangle. So this one congruent to this one here. So if we know AB and DC are congruent, we know these here are congruent. Well, what else can we say? Well, we know these are right angles because a rectangle has 4 right angles. So we can say that angle B is congruent to angle C by definition. So this angle and this angle. So now we can say that those two triangles are going to be congruent. So triangle ABC would be congruent. So ABC to DCB. DCB. And that's going to be by side angle side. So then we can say lastly that AC is congruent to BD by CPCTC. So if you think back to last chapter where we were doing all those proofs with triangles, whenever we were proving a set of sides or a set of angles, when we were proving those parts, we always use CPCTC. And before you use CPCTC, you have to prove the triangles are congruent, then you can use their parts. So that proof, all done. Don't have to worry about that one here. Now, what can we do with that? Well, we can do a problem like this. Find the length of FD in the rectangle GFED if FD is 2y plus 4 and GE is 6y minus 5. So FD, this diagonal, is going to be 2y plus 4. GE, this diagonal, 6y minus 5. Well, because it's a rectangle, that last proof told us that, hey, those diagonals are going to be congruent. We're going to set them congruent and solve that out. Okay, so y's on one side, numbers on the other. Because this side has the bigger y, I'm going to move the y's to that side. So that means I'm going to move my numbers to the other side. So 4 plus 5 is 9. 2y, or 6y minus 2y would leave me with 4y. So I divide by 4. I know that's not real pretty, but we're just going to leave this as y equaling 9 over 4. So we have to find the length of FD. So we're going to put this in here. So 2 times our y of 9 over 4 plus 4. Well, the 2 would cancel that. 4 would become 8 halves. So 9 halves and 8 halves will make 17 halves. So in other words, we're 8.5 for length. So 3 theorems, and we're not going to prove these, but theorem 612 says that if one diagonal of a parallelogram bisects the two angles of the parallelogram, then the parallelogram is a rhombus. So this is saying that first one that we did, theorem 6.9, just the other way. It's the converse of it. Theorem 6.13, the diagonals of a parallelogram are perpendicular, then we know it's a rhombus. And theorem 6.14, the diagonals of a parallelogram are congruent, then we know the parallelogram is a rectangle. So all these are converses to the first 3 theorems that we did. It's just saying it the other way. We're not going to go through and prove them. But what we can prove is, what are these shapes? So the first one, is it going to be a rhombus or a rectangle? Well, if we look, this diagonal is cutting through. It's making congruent angles. So bisecting it on this side and on this side. So what is it if we bisect the two angles of the parallelogram? Well, this one would be a rhombus by theorem 612. The other side, we know AC and BD are the congruent. So BD, AC, if the diagonals are congruent, we know this is a rectangle. And that's by theorem 614. So, again, questions, comments, concerned, pan me, send me an email, send me a message on Google Classroom, whatever works for you. If you have question or if something you kind of missed on the video, again, go back through, rewatch it, or pause it so you have time to write stuff down. Whatever you need to do, make sure you do it. But for now, we'll talk to you guys later.